130. Okay. And we have 4 cells, right? So which cell that we predict well? Predict well, that means have to be the same category as the observed data. The observed data here greater than 2,500 means normal weight. And what about the second one here? The observed, the real data is low birth weight, right? But we predict as normal weight. So 59 here, that is the wrong prediction. Okay, because the predicted said that normal weight, because this one is normal, is low birth weight. Predicted said that from the formula said that normal weight, but the real data said that low birth weight. So we wrong, right? We predict it's wrong. Nah? So here, this is the overall percentage of the prediction. It's about 68.8. 68.8 is about the right prediction over total. So it's gonna be 130 over 189. We got 68. Again, I will give you another example from my slide. Here, the example. Coronary heart disease, this is observed, this is predicted. So in this one, present, absent. So present and present together predict and observe. We got 3 to 8, right? And we got absent and absent together, we got 14. So 3 to 8 plus 14 is the correct prediction. Is that right? Because look at this table. Nah? So here 69.53 come from 3 to 8 plus 14 over total number of samples. This is a total number or total percentage of the correct prediction. Okay, so here we need to report this number when you fit the logistic regression model. The next one, after we got our model, we have to interpret our model. How can we interpret? We can interpret in terms of odds ratio and wall statistics. Okay. If we interpret in terms of the odds ratio, okay. This one I give you another example for interpret the odds ratio. Like for example, if we got odds ratio 2 and our dichotomous variable, I mean the variable X is smoking status. If we got odds ratio equal to 2, this means that lung cancer. For example, our dependent variable is a lung cancer. Lung cancer is twice as likely to occur among smokers than among non-smokers, okay, for 2 times. And if your odds ratio 0.8, how can we interpret? We will interpret in terms of 1 minus odds ratio and make it as the percentage. So the odds of having lung disease are 20% less. Okay, this one for the woman or for the smoker, then who do not smoke. Okay, so 20% come from 1 minus 0.8 and make it as a percentage, and talk in another way in terms of decrease or less. Okay, but if your variable is a continuous, for example, like an age, like you got the odds ratio 1.2, this means the probability of having low birth weight is 1.2 times as much as increase 1 year. Odds ratio is exponential of 0.014, right? Because it's a beta of weight. But in the SVS, SVS can give you automatically if you define this up here. Can you see in your table? It will give you an exponential of beta. Can you see that? So this is the odds ratio. This is the odds ratio. we got 0.986. Let me go back to my slide. Here, you see here, exponential. And we also can get the computer to report the 95% CI. The 95% CI, usually it doesn't show up. If you go to option, we add goodness of fit and 95% CI, you see here? Click on this. And the output will show you the 95% CI. Okay, so you can run. Can you get that? The 95% CI here? Okay. So the way we interpret our ratio here, 0.896. But we have to talk in the term that the reduction. So 1 minus 0.986 and times 100 to be percentage. So the 1.4% reduction in the odd or follow birth weight per 1 pound increase in weight of mother. Because weight, this is a weight, so increase 1 pound. Okay. And 95% CI, how to compute? The 95% CI is equal to the parameter that we estimate. Let me see. It's the exponential of the beta here, plus and minus C. C or the C value corresponding to the 95%, which is equal to 1.96. Okay, and times standard error. I don't know whether in the multiple regression do we have a 95% CI for any parameter.